Good afternoon and welcome to our sixth Friday lunchtime webinar. We're going to be taking a break after this one just to assess how it's all gone and take a bit of a breather. Previously on this space, we've been looking at Part O from a builder's perspective and all their thoughts on overheating. We've also done something on TM59 and how to use it in overheating calculations. We've done building performance evaluation, and this is our third in a series of webinars on heat pumps. We had our introductory one. We had air source heat pumps last time, and today we're moving on to ground source heat pumps. Now, if you want to see any of those webinars for yourself, and because you missed them or you enjoyed them so much you'd like to see them on repeat, you can have a look at those on our website or on YouTube. So just go there, and you should be able to find those very easily. Now, today we'll be looking, as I said, at ground source heat pumps. I'm really delighted to be joined by Ken Gordon, Chief Executive Officer of the Ground Source Heat Pump Association, and Alistair Don, Head of Building Performance at Wilmot Dixon. And so Ken's going to talk us through, give us a bit of a background, and Alistair will talk us through a Wilmot Dixon example. So we're expecting them to be able to present for 20 to 25 minutes, and then we will take questions. The session will end at 2 p.m. Or before. If we very much want, therefore, for you to ask us Q&A, otherwise it'll be very quiet in the second half of the webinar. And you should be able to see the Q&A icon towards the bottom of most Zoom screens. I think it changes slightly depending on which device you are on. Can I ask that if you keep your questions to topic, please? So don't ask us who's going to win the next general election or anything like that. If we can keep it to ground source heat pumps, that would be really good. And also, just because this question often comes up, we are recording this session, and this will then be posted on our website and on YouTube, and should be available for view sometime during next week. So I think that's all the notices. So thank you very much for joining us, and so I'm going to pass over to Ken, and who's going to kick off talking us through what we need to know about ground source heat pumps. So Ken, it's over to you. Thank you very much.
Yeah, thanks very much then, Chris. I'll just share my screen now, and it's that one there. There we go. So.
That's good.
Okay, so right, so yes, Ken Gordon from the Ground Source Heat Pump Association. Thank you very much for joining us on this session here, and it's really good to be able to talk to you guys about ground source. So let's go. What I'd like to cover today is 4 topics really: how a ground source heat pump works, low temperature heating systems, the additional benefits of ground source, and how to install ground source in a housing development. So first thing is, a heat pump works like a fridge in reverse. No, it doesn't. It works exactly like a fridge. How does it work like a fridge? Well, if you look at the little green box there, that's the heat pump, and the connected to it is a tube that goes all the way down a borehole, meets the U-tube at the bottom, comes back up again, and that transfer fluid, which is just water and glycol, it's at 6 degrees and it's been chilled by the heat pump. So it goes down into the ground, which is at a temperature of 10 degrees. On average in UK, it's a bit colder in the north, a bit warmer in the south. And so it gets warmed up and it comes out at 8 degrees, goes into the heat pump, the little green box, which says, oh, hang on a minute, you should be 6 degrees, so I'll cool you down. Then, just like your fridge, if you put your hand around the back, it's nice and warm because that heat's been rejected. It's back to 6 degrees, and it just carries on like that. So instead of it being blasted out the back of the fridge, it's put into the heating system, which could be radiators or floor heating. So talking of floor heating and radiators, just really wanted to just go to some sort of basic physics, really, on why we like to see low temperature heating. And this is not just for ground source or air source, it actually applies to gas boilers as well. And if you could just look at the little diagram on the left-hand side there, we're talking about this. This is just to get your minds on pumping water. And if you have a reservoir at the bottom of the hill there and you're pumping it halfway up, then it's clearly going to take much more energy to pump it to the top of the hill. And that's just, logic. So if you now move over to the right-hand side, you'll see that we're pumping heat. But instead of it pumping heat up meters, it's actually temperature. So if you're going to half the temperature, then it's going to take half the energy that it would take to go to the top. And that's really the basic principle of low energy heat. Keep your emitters as low as possible. And of course, radiators are difficult. They don't really work terribly well much below 50 degrees. So we often suggest that floor heating is a way forward. But floor heating's more often than not buried into the concrete of the floor, which means that it takes a long time for it to warm up and a long time to cool down. And I just ask everybody to have a think about overfloor heating, because it's over the floor, and there is some pushback on that, but it can go over suspended floors, it can go upstairs, downstairs, anywhere. And I'm often said, well, you must bury it in the concrete. And I go, why would you do that? You don't bury your radiators into the wall. So why ground source heat pumps? Well, we like to think that they're cheaper, quieter, require less maintenance. And in a recent document, we sort of listed the pros and cons, and I'm not going to go through these all now, but you can see that there are significant numbers of benefits from ground source, until you get to the bottom where you see you need a borehole and it's a higher capital cost. And that really is where the crunch comes. So you've got to really think, though, that although they do cost more initially because of the infrastructure required, they are much more efficient than other sources of heating. And so what we've developed is really to look at heat pumps being connected to a heat network. And here is what most people think of a heat network, which is a centralized area of energy where the water is heated up and then pumped to different places in insulated pipes. Now, our type of heat network is different. We call it a shared ground loop. And there we have just the boreholes are shared with houses, because with new modern low energy homes, you probably only need one borehole per 2 houses, or if you were going for passive house, maybe even more. And how does this work? Well, Ken's slide here shows that think back to the gas network. So we are planning to do we are doing this in many places, where instead of having a yellow pipe coming into a house, we have 2 black pipes coming in that supply the feed and return from the ground loop. And this is kind of the way it works. Is that so this is the way it can be done for housing developers, is that we can get a heat network owner to actually pay for and install that network for the developer. So they would engage with the housing developer, and they would agree that the groundworks are covered. Then part 3, or item 3, the network owner would then design the system, drill the boreholes, link them together, and then the developer would come in, build the houses, and when the houses are up, the heat network owner runs 2 pipes, feed and return into each home, and the developer installs the heat pumps, whatever they like, in their own homes, or the homeowner can put just the same as a gas boiler. Then what happens is the heat network owner, who's paid for all this stuff, they charge a monthly standing order to each home occupier. So the reason it's not really kicked off at scale yet is because there is legislation coming on heat networks. And what this does is it protects the investors and owners, because at the moment this can be done, and many housing developers have actually done it themselves. But it is difficult, because you have to have special legal protection. But once this legislation is through, there'll be protection for any investor, in that they will own that as a utility below ground. But equally, on the other side, there'll be protection for consumers connected to these heat works, because they're connected to a natural monopoly. So it's a win-win for both sides. We're very lucky that the government buys into this, and there is huge investment in that whole area. Members of the Ground Source Heat Pump Association who are involved in doing this stuff at the moment, for example, are Rendesco, and they work with lots of housing developers up and down the country, offering that kind of service. We've got Synergist, who do the same thing, but general with social housing. And look, here's an interesting one, PH Jones, Ground Source. Oh, that's British Gas. So now we're beginning to get quite serious here. And there's another one, Scottish Power. And they really have bought into this very much so, because, you know, if you're not selling gas, then, you know, this is a fantastic alternative. So here's the Kensa model here. As I said, you just pay a small standing charge to access it. And they're saying this is how it works, £350 a year. If it had been 360, it'd be easier to divide by 12, but that's the way they've done it. And what about inner cities? Well, again, another one of our members is Celsius Energy, and they've developed this directional drilling, or rather inclined drilling, where they can drill out right to the boundary of the property. They know exactly where the boreholes are, and that will feed into inner city buildings. And that is really my flight through the whole process of ground source heat pumps. So I'll just stop sharing now. There we go.
Thank you, Ken.
Good afternoon, everyone. Hopefully you can hear me okay. I'd like to pick up the baton there from Ken and take you through a case study of a Wilmot Dixon project that I was involved in over the last 4 or 5 years, really to act as a little bit of an example of how, from a contractor's perspective, working with a social developer, as you'll see here in Bristol City Council, we installed one of these shared array ground loop systems, and I just wanted to share a little bit of the journey that we went on, how that system was selected, how we approached the design and build process as a contractor partnering with the developer to deliver this project, and to maybe share some of the thoughts about future direction and how ground source sits in the environment for heating hot water systems in residential projects. Just to say, I'm working with Wilmot Dixon, and we have an internal team led by myself that looks at all of the energy efficiency and carbon performance of the systems that we install in our buildings and homes. And we partnered in this case with Kensa Heat Pumps and Bristol City Council, our customer, to look at this project from trying to learn really as much as we could about how ground source heat pumps performed in operation, and also how the process of design and build and installation worked. So I'll just take you through that learning and hopefully provoke some questions for you to ask later on. So just to describe a little bit, the development in Ashton Rise in Bristol, it's a social and private sale development, mixed tenure, 130 new homes on a brownfield site on the edge of Bristol, mixture of 2-storey homes and apartments, so a variety of different contexts of heating. From an energy performance and fabric level, the homes are pretty decent, not stretching to net zero or passive house, but probably in line roughly with 2021 building regs. These were built to previous building regs. So yeah, decent fabric quality, a little bit of innovation in the build system, but primarily pretty standard high quality social stock with a private sale proportion in the project. And Bristol City Council are the landlord and developer, and acting as the sale party for the private homes as well. So Ashton Rise is on the edge of the Bristol conurbation. So there were a number of potential solutions that the customer looked at here. It's fair to say that Bristol have a pretty progressive planning policy, and that was quite material in looking at the pros and cons from a sustainability standpoint of the different solutions. It's outside of the Bristol urban heat network area, so at the time in around about 4 or 5 years ago when we were making these selections, gas was still an option, but Bristol had already decided that from a planning policy standpoint, they were really already on the journey of gas elimination and going to 100% electric systems. So in realistic terms, the alternatives were between different heat pump solutions and potentially a central heat network providing conventional LTHW through HIUs to the homes on the project. So a lot of different evaluations of balances of technical risk, cost, supplier confidence, and so on that were undertaken with Bristol City Council, but the eventual best balance of benefits versus risk and cost was decided that the shared loop ground source approach would be their choice. In that time period, that was the last of the periods where RHI was available as a cross operating cost benefit to this ground source heat pump capital cost investment. You've heard it from Ken already that there was a more significant capital cost investment. Bristol City Council, as the social developer, were prepared to make that investment in this case, but that was offset to some extent by a future payment stream of RHI. That doesn't exist now, but the alternative of leased models that you've had from Ken are I guess the alternative route to make that an operating cost asset or operating cost model, if you like, rather than a capital investment for the developer. So having made that decision, we went in partnership with the council, did quite a rigorous supplier selection process, looking at the available choices from a technical and commercial risk, how we would integrate the heat pump system with other packages. And Ken's so-called shoebox ground source heat pump system that you see there, quite a large shoebox, size of a camping fridge, roughly, to give you a more realistic description, is the unit that was installed in a ground source shared array system. So each home, each apartment has one of the heat pumps. It has very conventional LTHW and plumbing systems. In contrast to Ken's comments there on underfloor, here we were using just additional area rads with a conventional hot water cylinder, heat pump feeding the cylinder in hot water mode, and the rads in space heating mode, conventional controls, plumbing, and we integrated the heat pump package as a single commercial package of groundworks and heat pump installation and commissioning in parallel with our regular mechanical package for domestic mechanical services. So a relatively straightforward integration, I think, with existing supply chain partners for construction. Just to give you a flavour of what the site works look like. So drilling operation produces 36 in total boreholes for this development. So 36 boreholes shared in clusters across 130 or so homes, each one with a flow and return into the ground, as you've seen in Ken's diagram, and a manifold of subsurface HDPE piping with high integrity welding to ensure a very integral system. You see on the right there an example of the sort of manifold devices that manifold the wells together and provide flow and return to each of the homes. So I guess from a construction standpoint, quite unusual in that you've basically got M&E works of a fairly substantial nature and key performance aspects of the project happening at groundwork stage. That's very unusual in a homes development, and that project management sort of difference was certainly something that we managed through the process. You can see there a bit more of the trenching and how the system relates to the foundations for the projects. You'll see a little bit of the testing equipment that's used by the supply chain there to carry out a series of quality and pressure tests during the different phases of the install. And we, because this was the first project of this scale and nature that we'd done using this system, we put quite a bit of our own resource into that quality checking process to make sure that we were really satisfied at various key milestones in the package delivery that it was the quality and integrity of that ground asset was ensured. You can appreciate that that's the core of the system and inaccessible primarily at future points. So it's important that we verified that and reduced risk for everyone concerned. And you can see there an example of a finished sort of install. So at floor construction and groundworks completion stage, just going out of the ground and up into the superstructure, we've got a flow and return loop, which eventually then would be connected to the heat pump in the utility cupboard or under the stairs of the project. You can see there's some of the construction detail using a large format block system. So yeah, as I mentioned, the difference between ground source and air source from a quality management and management of risk point of view is reasonably significant, I would say. You know, it's a good quality supply chain with some very well established and experienced partners, but it is quite different to conventional sequencing in terms of the groundworks element. I'd say that you know that part of the system aside, and ensuring that all of those physical and quality checks are ensured, the rest of the process is pretty similar to normal house build and first and second fix and commissioning and completion and so on. But yeah, an interesting learning exercise for our construction team. And we also did quite a bit of work with Bristol City Council to help them understand and explain the differences from an O&M standpoint and an occupier engagement standpoint, to explain, you know, some of the differences about how heat pumps differ from conventional heating systems for occupiers, and to work with them to make sure that, you know, appropriate maintenance and monitoring was carried out. The most interesting example of that process, I think, was that we undertook an 18-month performance study on a sample of 4 of the homes in the development. We essentially metered those up with additional equipment in a collaborative exercise with the council, their sustainability team, and Kensa, and conducted quite a detailed quantitative analysis of energy performance and efficiency delivery on the systems, looking at different seasons, different conditions, and so on. We also carried out some qualitative interviews with occupiers, how they were dealing with the system, how that manifested itself. And you can see there in the central photo at the bottom, an example of a finished system, so conventional hot water tank, and plumbing distribution with the Kensa heat pump in an under the stairs location. Just from a feedback standpoint, the headline sort of results on the study were that, you know, as claimed and as designed, performance efficiencies on the system were generally achieved. Some variation depending on operating conditions and patterns of use, particularly the balance of hot water and heating. And as you'll remember from Ken's example, the proportion of hot water and space heating demand and the patterns of use in the home are, you know, that affects any system performance, and is particularly significant in heat pump performance, ground source and air source. So that's a factor to bear in mind. And from an O&M and maintenance and defect standpoint, generally, you know, the system has worked out well. We're 3 and a bit years post completion now, and I'd say our sort of degree of defects management and so on has been substantially lower than an average residential project, which is encouraging. So I think in terms of outcomes from the project, our customer feedback so far has been predominantly positive. It was a very useful exercise to carry out quality management and performance evaluation through that process, and one that you know, we've taken into future projects and collaborations with other customers in other scenarios. I just wanted to end by maybe just touching on a kind of a little bit of thought-provoking choice around the 3, I guess, as a developer for social customers in both low density and medium and high density scenarios. There are definitely pros and cons of the ground source heat pump solution versus air source heat pumps at the top, or more complex ambient network in apartment systems, water source heat pump systems, which you see on the bottom there, in a development in London that we're that we've constructed. I think the key takeaway for me in any of these is that, as well as all of the on paper performance comparisons between one system and another, it's really important as an industry, and I'm sure the Future Homes Hub would support this, that we evaluate how design and build expectations translate to in operation performance, both from the occupier, the landlord, the customer, investor in the project, the developer, to make sure that, you know, when we as an industry and a deliverer of new homes, together with our heat pump partners, are making solution proposals, that we can genuinely do that recommendation with the knowledge of how systems perform and the pros and cons in operation, as well as in the home energy model or SAP, or on paper, or in any other way that you care to evaluate them in a cost plan or otherwise. So yeah, a food for thought there, and perhaps to stimulate a little bit of discussion in the context of the webinar today. So I will stop sharing my screen and hand you back to Chris.
Alison, thank you so much. Thank you, Ken, as well. Really, really interesting. Lots of food for thought there. And Ken has been busy multitasking, answering questions as they've been coming up. And I'm going to be slightly naughty and ask him to actually revisit some of those and share it with the group, I think is the so actually, Ken, you thank you for answering the questions that have been going on, but I think it'd be good because not everybody will be plugged into the Q&A. There was a question about life expectancy and how we can be confident about the increased life. And I guess actually, I mean, you know, there's an inevitability that we're comparing this against gas boilers and with air source heat pumps. So the claims for ground source heat pumps are longer. So I don't know if you want to just share a little bit about how you feel that you can come by that.
Yeah, well, certainly, you know, ground source heat pumps have been around for a long time now, about 50 years. So it's well-established technology, nothing new. They're improved all the time because, you know, we put inverters and control systems on them that are more efficient than they were originally. But the technology is well established, and you know we're quite happy in saying that these units inside the home will last 20 years, and you know, often if I'm asked that question, I'll say, well, have you got a refrigerator in your house? That's a heat pump. And people go, yes. I said, well, when did you last throw one away because it broke? And most people go, well, actually, you know, it's maybe the wrong color or the door came off or something. So these little compressor units, they do have a very long life expectancy.
Yeah. Okay. I mean, and I guess there are not very many moving parts, are there? I mean, to put it bluntly, I suppose. Okay, and in terms of ground conditions, and I mean, because I mean, you know, somebody says, what's the main negative, and you said you've got to dig up the ground, but could you just talk us through about, you know, are there differences in ground conditions? Does that vary? Depends on when, you know, how do you make decisions between whether or not you're using a borehole or you're using loops at a much, you know, spread over an area?
Yeah. So the loops spread over an area, I didn't go into those. They're horizontal ground loops or slinkies, and you have to dig a series of trenches. Probably only about 15% of installations now use that because it does require quite a large area of land. And the disadvantage is that until you get to 10 meters below ground level, then the temperature of the ground will be cold in winter and warm in summer. So that's why we do prefer the deep boreholes down to probably about 200 meters if you're doing long arrays of them. How do we know how many? Well, that's where I was just saying in the chat earlier, is that it does really need to be designed by a mechanical engineer to really understand, because this is new technology, you see, in terms of digging into the ground. You know, when everybody's doing these, you'll know that your neighbor had one and you know exactly how deep they went. But at the moment, we really have to look at the geology, and each different type of rock will allow heat to flow at a different rate. So in Scotland, where I'm based, granite is great stuff because it really it's 6 times more efficient than London clay. So it's in the north of Scotland, these things are just a no-brainer really, because it's just there readily available. So that's really what happens is you need geologists tell you what's underneath. And then what we do is we do a simulation design on it so that over 20 years, we will not pull out so much heat that the rock is chilled, because we want to reach a steady state where the heat that's flowing from the rock or the ground, which comes ultimately from the sun and a little bit from thermal transfer from the center of the earth, we just get that balance so that the whole thing works. But what we didn't say earlier is that you can also use your system in reverse, so you can cool the house using a heat pump, and that heat then is pushed back into the ground and stores it for the next season, because, as I say, it's a pretty slow flow process for this stuff to come out of the ground.
Okay,
So
and
maybe I can a couple of points I could illustrate on just to give examples of that issue, of those 2 issues actually on Ashton Rise. On the design of ground condition specific stuff. An additional activity we did on Ashton Rise was to undertake a test borehole as part of the initial part of the drilling program. On the basis of the thermal performance results that were measured on that test borehole, and that was all integrated in our package with the supplier, we made a transparent evaluation of the performance of the ground in reality as measured, and we'll use that to revise and verify the final design. So there was a contractual mechanism for achieving that in the context of the supplier, which is an important risk management exercise, I would say, for a large development, and cost optimization exercise. On the cooling and heating side of things, whilst the Kensa heat pump as it stands is not a reversible heat pump, what we did on the Ashton Rise development was to allow for the connection of the passive ground loop itself at 10-degree water to be used for future a potential future effectively energy-free passive cooling system, and that was one of the things that the customer wanted to. One of the additional advantages actually of using ground source system, that it could offer that potential to essentially use the ground loop through a fan coil unit or some other kind of ventilated radiator system at a future point to provide cooling from an asset that's already exists, rather than an active cooling energy consuming system. Yeah, so that's a consideration.
And while we're just talking about loops and all of that sort of stuff, Mike Brabant asked whether or not there was about the design life of the components underground, I suppose.
Yeah.
So is there an issue there? Do different ground conditions change the design life of components underground at all, or?
I think Ken's best to answer that one.
Yeah. So, well, when you drill a borehole, there's a hole in the ground, and fortunately, that stays there for a long time. I guess if there was an earthquake or something, it would destroy it. And the pipework that goes down, the most of the ground loops you buy will be what they call RC polyethylene, which is reduced crack, and it's just the high quality polyethylene, which is said to last for 100 years or 120 years. But I mean, if you look up the half-life of polythene, what is it, 30,000 years? Because every bit of polythene that was ever made is still on the planet somewhere, isn't it?
Okay, thank you.
I mean, on Ashton Rise, just to expand on that, from a commercial and sort of risk evaluation standpoint, it was evaluated for 25 years of asset life, but that was purely a commercial evaluation point. I guess it's probably worth pointing out from a general standpoint that you're talking about high integrity plastic piping that's been pressure tested, fusion welded, and encased in cement, essentially in the borehole. So I think the documented issues around risk for the underground asset are pretty low. The risks are mainly in the quality of the construction and installation process in the first place. And at the ground to above ground interface is probably the biggest risk area for that, I would say.
Okay, right, thank you. And we had a question about potentially interfering with pile foundations. Is there potential there? You also talked about products which combine both, Ken, in your typed answer. Do you just want to expand on that a bit for us?
Yeah,
please?
so the Ground Source Heat Pump Association has a code of practice, well, actually it's a standard rather than a code of practice, on thermal piles, which is just basically how you can use existing piles and you put a ground loop inside them. And we've got new members who have been putting in piles for years, and they went, I can't believe that we don't do this every time. So, those options are very much there and, tried and tested.
Okay.
Another perspective from it, I think for low density developments like Ashton Rise, I think the contractors and developers' preference, and by far the lowest risk option, is to locate arrays outside of the building footprint. I think we had a question about access as well in terms of where manifolds are located. Unless there's an overriding site reason to go to higher density, to have overlapping building footprint and ground source assets. And clearly that would be needed in a high density urban situation where, sometimes, as the example that Ken just illustrated, for most, most regular low to medium density UK style developments in normal geology, then I think the land area to avoid overlap is the way to go, in my view.
I would agree, yes. Yeah.
And another one that you answered, Ken, but I will ask it for everybody else as well. Is Vikram asked about who would normally design the whole heating system, and would it be the ground source heat pump manufacturer? Do you just want to expand on that as well, please, for us?
At the moment, you do have manufacturers that are designing systems, but they really they're doing it just to get the system moving. So Kensa have a separate contracting company as well as their manufacturing area. So it really does need to be somebody that designs the system, and it's pretty straightforward, really. You just do as you would normally do your heat loss calculations for the building. From that, you select the heat pump that you want and the controls that you want, and then when you've got that, you just need to know how much depth you want on the boreholes and the network to provide the heat when it's required. And in UK, we actually do design to the coldest day of the year on average. In some countries like Scandinavia, they perhaps just allow it to go over to direct heating in the midwinter. But then when you're paying 4 times the price for electricity in UK compared with 0.85 times the price in Sweden. So in other words, it's cheaper. Electricity is actually cheaper than gas. So in those countries, it makes sense just to just top it up with direct electric. But we're not there yet, I'm afraid.
Yeah, on Ashton Rise, we actually did have an integrated groundworks and heat pump design package that was done in conjunction with our heating system distribution and controls package, if you like. So there was clear ownership for design responsibility for the heat pump supplier and installer, and also a close integration with the hot water and heating system delivery side. So yeah, I think we felt at the point, at least in the evolution of the technology at this point, that was the way that we wanted to go to reduce risk. But clearly, it could be done. It could be done in other ways by different package divisions. That would probably become more standard, as Ken's suggesting, in the future, I think.
Yeah, but I think once we can get utilities in that take all the risk away and all the cost away, and just charge for access. Not for heat, but just for access, then it really will make a massive difference, and it'll just be kind of like a no-brainer.
Okay, I mean, and on that point, I guess that's all to do with when we might see heat network legislation.
It's coming. It's on its way. It's the consultations are finished now, and we're just waiting for the final.
Oh, right. So there's been consultation. So we're thinking we might see something. Well, I mean, it's an election year, so nobody knows anything, do they? So I'm about to ask you a really dumb question, but any have you looked in your crystal ball and seen anything?
I would like to think in the next couple of years, really, that it'll happen, because certainly it depends who comes out the other end of the election. But both sides of the House are very much in favour of this technology, So I don't see anything holding it up. There's nothing contentious about it. It's just a win-win all around.
And
Yeah.
and linked to that customer experience, Sean Wilson was asking if there are any monthly standing charges for the end user. I don't know if that's specifically with regards to Alistair's project or projects in general.
Yeah, I mean, I can explain how
maintenance?
Ken can give you some other examples. I think for Ashton Rise, no, that effectively there was no service charge or standing charge specifically to do with the heat pump. There's certainly no as used charge or metering in any way whatsoever. So in this case, the investor and the asset owner was Bristol City Council. You know, there's a clear division in the lease for new homes. There's an obligation for Bristol City Council as the asset owner to maintain and supply that. And there's there's a service charge for the private owners for the development as a whole, but it's not specifically linked to the heat pump system in any way. And for the social customers, it's not, there's no rent element that's associated with the heat pump asset. So effectively, Bristol City Council as a heat pump network developer have done a private network system for their home customers and their tenants in this case, and other social developers have done the same thing. But Ken's legislation will take that into a different kind of league, I think. Yeah.
Okay, and a couple of questions about the occupant or customer experience of ground source heat pumps, both in terms of their understanding of how they operate. So Vikram was asking about that, and because we're all very used to the idea, we have a boiler and it comes on. You hear this sort of, you're woken up normally to the sound of your boiler roaring into action, and half an hour later the place starts to feel a bit warmer, and then you turn it off and you go out to work and you turn it back on again. It's a very traditional heating pattern. Do you find that how and I suppose I'll start with Alistair. How have you been coping with that? I mean, is there an occupant education that you have to do, and and how are they coping, and how do they cope with what I suppose they might perceive as being a bit of a lag, whether or not, and is that lag any different between that and any other heat pump? Probably not, I'm guessing.
No, I mean, in terms of if you compare heat pumps to heat pumps or any sort of alternative to ground source that's another kind of heat pump, there's absolutely no difference, I would say. Yeah. The difference is in as you kind of alluded to, Chris, in the psychology between traditional UK high power boiler systems with high temperature emitters and periodic heating as opposed to more continuous space heating. So in the context of a modern approach, which is the case across virtually all new build now, it's really just a question of a choice of system rather than otherwise. If you're looking at a lower temperature, more continuously on and therefore lower power delivery heat pump system, I think in the space heating side, it's really just that psychology adjustment between that kind of system and a more conventional older gas type system. On the hot water side, there are obviously the psychological differences in the presence of a tank rather than a combi boiler, and that's our combi boiler versus hot water tank psychology for occupiers is probably more of a difference than on the space heating side. I think the space heating side with ground source and air source, frankly, just works okay. It's in a well insulated home, that's a fairly easy adaptation pattern. And on Ashton Rise, any of the issues that we did have around occupant understanding were mainly around refill times and reheat times on hot water tanks, and the difference in heat pump systems for storage versus combi scenarios. So that's, I'd say that's a general heat pumps versus gas boilers issue, and heat and ground sources is absolutely fine in that regard. No issues on noise or acoustics. That was one thing that we were quite sensitive on, because it's a box with a pump in it and it's inside the home, not outside the home in the garden, as with an air source heat pump system. Then we did quite a bit of work looking at the risks around that, but that's transpired to be completely problem free, really.
And is it completely silent?
Well, it's as silent as a fridge, roughly. Sorry, a clunky fridge, you could say. A clunky fridge under the stairs. Yeah, I don't think I'd want it in my bedroom, But under the stairs or in a utility cupboard is absolutely fine. We've not had any issues with that on that project.
Okay.
Yeah, I mean it depends which one you get. Certainly my one is as quiet as a fridge. It doesn't clunk at all, even when it's flat out. When it was installed 2.5 years ago, we switched it on and we haven't touched it since. It just comes on and off with the seasons. It's just amazing, and the house is just kept at constant temperature throughout the year. They are just amazing bits of kit. But I think the real question is down to radiators versus floor heating, honestly, because radiators they don't really radiate, they convect. So once you've cut the temperature down on those, they convect less effectively. And
that's certainly true, Ken. Yeah. I mean, all I would say in defence of that, or in counterpoint, is that we haven't had any issues on that project or others for that reason. But yeah, I think if you've got plenty of rad area and the psychology of not having a hot radiator isn't a problem.
But as climate change is important, the less energy we need to use, the better. So if you can cut your temperature down even below where it wouldn't be effective in a radiator, then that's
a fair point. Yeah.
Okay. Couple of borehole type questions, which we may have answered briefly, but I just want to make sure that we have. So Andrew Lamb from GTC was asking about traditional low-rise development. Where would you foresee the boreholes and manifolds being located? And he says, I assume you avoid private gardens, but where do you go?
Yeah, so on Ashton Rise, the boreholes are sometimes within private gardens. What we made a decision to do was put all of the above ground access outside of private gardens, so they're either in other gardens or in the street, essentially in the public domain. Yeah. Right.
Okay. Yeah. And Ken, question for you. From no, it's anonymous. That's why I can't remember their name. It's about ground chilling effects. I mean, I think back in the day, I definitely heard horror stories about ground chilling effects. So I think it'd be quite good to actually explain about why people saw ground chilling effects in the past, and I'm assuming, well, you definitely aren't going to see them now if you've done. I mean, but are there things you need to do to make sure you definitely don't see them now, and and does it get worse over time? So can you just sort of talk us through that?
No, it's a very good question, and the ground will chill as you draw the heat out of it, because you're tending to draw more in the winter than in the summer. So what our little simulation program does is it works out over 25 years how much the ground will cool and ensures that it will stay well above freezing. And it's a sort of slow decay over the years. So as the ground temperature drops, you reach this equilibrium level, probably just halfway between the 10 degrees, maybe about 5 or 6 degrees. But that is just assuming that it's not recharged by any other means like an aquifer or anything. So it is the worst case scenario. But really, if it's designed correctly, it's kind of flat line, so it'll sort of come down and then it'll just stay like that forever, really. Okay. But it is I mean, we use two different types of design. I tend to use the Swedish design because it works for Scotland, which is Earth Energy Design, and others use GLD, which is an American design, which works for the sort of London clay type stuff.
And how do we know that our designers know what they're doing? I suppose.
Right. Okay. So I
suppose where's the QA in that?
Fair question.
So it is a good question, but I think
nobody was asking that. But I was thinking, to know that.
Yeah, no, well, Alice has already answered that, because these are desk studies. So if really you're in a development where there's more than 10 boreholes, it then becomes economically sensible to do a thermal response test. So therefore you drill your pilot borehole on the basis of the desk study, and then you test it to make sure that you are able to get the temperature that you want without pulling the ground temperature down too far.
Yeah, that's what we did. We also did
Yeah.
an additional bit of due diligence where we had a third party consultant review the ground design of the original consultant to verify that the risk approach to modelling and everything Ken's just referred to as was robust.
So it's all quite scary stuff, which is why, you know, we're so much in favour of getting this as a utility, because it takes all that risk away from the developer, unless the developer really wants to invest in this sort of technology going forward. So risk averse, it'd just be great, and then the developer can go, well, I'm not getting gas in here, I'm going to get a shared ground loop utility.
Okay. Now, I've got a question here. I'm always wary of asking questions where, for the life of me, I can't work out exactly what the question means, because there's I can't remember. My brain's going a million miles an hour while I'm doing these sessions, so you'll have to bear with me. So Sam Hansen said, has any assessment of embodied stroke whole life carbon of an SGL? I couldn't think what an SGL is.
Shared ground loop.
Thank you very much. System being done. Interested if you will earn back the upfront carbon cost with the gain in operating efficiency when factoring in a decarbonised grid.
Yeah, well, it's a very, very good question. And, you know, we have to be careful where we go, because, you know, we're replacing perfectly good boilers with heat pumps. You know, so the embodied carbon is a very, very good question. But for shared ground loops, they have been looked at, not in I was going to say in depth, sorry about that, but they've not been looked at in huge detail. But we are, you know, confident that it is a sustainable way of doing it, because, you know, if you're doing embodied carbon, what's your lifespan? I mean, how long does a hole in the ground last? You know, you can extrapolate it as far as you need to be, and we are reasonably confident that it's a good way of doing it. Yeah.
But I mean, we may be a bit thin on the ground for studies. Would that be a fair?
Yes, it's like all of these things, really. I mean, there's not even an established method of working out embodied carbon. You know, which method do you use? And I don't know, was it you said that you'd had a session on embodied carbon? I think you said earlier, didn't you?
No, we haven't actually. No, we probably should have, but we haven't. Yes,
an interesting one.
That'll be coming up,
especially embodied carbon of M&E services. I mean, if I was just doing a mental kind of calculation in my head there, I think in the above ground embodied impacts and materials bill, if you like, of quants, I don't think there's a substantial difference between ground source and any other kind of heat pump. So the only real bit is what is the embodied impact of the underground asset in respect of the drilling, piping, and cement and mortar materials that are used in the groundworks. So interesting question, actually, and yeah, I think an excellent one for the GSHPA to take up. It's not something we evaluated for this development, I'm afraid. I'd love to be able to give you the answer, but we didn't do that evaluation for this. I guess my only thing to say is, I'd say that, you know, gut feel says that the underground asset carbon investment is substantially less than the above ground carbon investment. So it's probably more a question of the development as a whole. It's probably not a material sort of a point of the whole development in embodied carbon terms.
Yeah, we'd like to think, though, that you know, the ground source units will last longer than air source, because this is just a simple fact that, you know, we don't have rotating fans and bearings, we don't have defrost equipment, and, you know, the unit is indoors, so that, you know, I think it is accepted that the ground source heat pumps will last longer than air source by all parties.
I'm going to try and rattle through last few things, and thank you to anonymous attendee for reminding us about CIBSE TM 65.1, which is about embodied carbon. I think that is of services, I think. As well.
Yeah, it is. Yeah. That's right. Yeah.
Thank you very much. Those who are better remembering numbers than me. That's good. So I've got $1 million question, which is getting a bit commercial. How many units on a development, says Gary Phipps, how many units on the development would you need to make a communal system viable versus an air source heat pump? Ooh, I imagine that's impossible to answer. But, you know, are you able to make any stab at an answer of that? Because it must vary by site. But
What's
Ken, would you
your
like to
thoughts,
take
Alistair?
a view on that? I think it depends what you're comparing it with. On this development, 133 homes, it was definitely a preferable from a risk and predominantly O&M management cost risk compared to AirSource, I think was the evaluation that the customer used. I'd say gut feel probably 40, 50 homes upwards it would be worth looking at just from a simplicity, complexity point of view, but that's not based on any definitive analysis. I imagine that number may be quite a different set of comparisons if you're looking at a utility investor, looking at what are the fixed costs of my utility investment versus variable cost of the number of homes.
Okay.
Yeah, that would be an interesting one
That's
to
your
know.
guess. Okay.
I believe Kensa have made propositions for systems as small as 20 or 30 homes on a shared investment basis, but Ken may know that better than me.
No,
I know I don't remember what their figures were exactly, but it really just depends on your input cost, doesn't it? Because clearly if you've got to go to the due diligence that Alistair's gone to with 2 designs and a thermal response test, it's risk versus reward, isn't it really?
Okay, and I've got a question about who are the main players delivering ground source heat pumps for new build. Now, you mentioned some people in your presentation, Ken, and the presentation will be up on our website. It should be sometime next week for those who want to go back and refer to that. But can they get hold of more contact details from your website?
Absolutely, yes. There's a members directory on our website, so just pop in there, and I've mentioned some of the names earlier because they are members.
Okay, right, yeah. Right, now this one Josh asks a question saying, considering the cost involved and reluctancy for warranty companies to cover ground source heat pumps, do you see this technology taking off in the mainstream like air source heat pumps? So I suppose the first question is, I don't know about the premise of this, about any potential reluctancy of warranty companies, but Ken, are you able to shed any light on that?
Yes, I mean I wasn't aware that warranty companies weren't willing to offer warranties on it, but it would be understandable. If you look at the Ground Source Heat Pump Association standard for drilling boreholes, you will find it in there a method of testing, and we have members who will undertake that testing and certify it. And I believe that if that certification is produced, then a warranty should not be a problem.
Okay.
I've certainly not heard of any issues specifically to do with NHBC or other kind of private sector warranty certification kind of approaches. Maybe that's an issue, but it didn't arise on this project.
Maybe Josh could just quickly put something in the chat on that.
Okay, well he's got about 2 minutes to do that. So Josh, if you have a particular problem provider of warranties, we're probably quite keen to know who they are. A question really, which I suppose is linked into this heat network legislation, which would probably answer this, but what do you do in between time, is how do we make sure that customers are protected when they're tied into a source of supply for heat? And are there any schemes or anything that currently exists that offers customers some protection?
Oh, definitely. I mean, you can't do this without having the protection in it. I'm not sure about Alistair's because it's a sort of a more of a holistic approach, but certainly, with the Kensa approach, the Rendesco approach, there is definite guarantees. But each one has to be done as a sort of separate legal entity, which just holds the technology back. Okay,
and somebody's mentioned the Heat Trust has just come up.
Yeah, the Heat Trust, yes, of course.
Yeah, all proper shared ground utilization, the Heat Trust. And just as a closing point, I think it was in you probably rushed through it in your presentation, Ken. But
Sorry.
but what sort of coefficients performance are you typically expecting to see out of ground source heat pumps versus so we know air source heat pumps are, am I right in thinking, Alistair will correct me if I'm going to quote a number here, but they're sort of between 2.5 and 3. Is that about right, Alistair?
On an average heating hot water balance, probably. Yeah.
No, Ken. So what sort of
maybe closer to 2 to 2.5, I would say. Yeah.
And Ken, what are you seeing in ground source heat pumps, and what's the difference with that and seasonal COP?
Okay, so basically the answer is watch this space. We all know that ground source is going to be more efficient than air source. And DESNZ are about to publish up a report on the differences between air source and ground source based on the Ofgem data that was taken for all the domestic heat pumps that were installed under the RHI, which is the Renewable Heat Incentive. So that's coming out shortly, and you'll notice that there's a significant difference between the efficiency of ground source and air source in there, which yeah.
Well, I'm just going to wrap up here. I'm just going to say Josh has come back. Thank you, Josh. With the answer, yes, I work with a private provider. I don't know work for or work with a private provider, and they do not cover ground or air heat pumps.
Oh, okay, right. Well,
which is extraordinary considering. I don't know what they think they're going to heat their houses with, the new builds. This is sent out to clients prior to taking out the warranty provision. Unsure why. I can find out and advise in the future. I think Josh, I think Ken in particular, and me also, will be very interested if you want to come back to us on that. So if you need to contact us, and
please do
so at you can go to admin at the Future Homes Hub. If we haven't answered your question, I'm really sorry, because I've just turned 2 o'clock, and I do like to promise people they can go off and do something, go off to their other meetings. But we want to say thank you very much for joining us today. Thank you so much to Ken and Alistair for doing the presentations and answering the questions. If we didn't get round to your question, please email us, and I'll forward them on. But it's been really informative, and thank you so much to everyone for joining us today, and have a good afternoon.
Thank you. Bye.
Thank you. Bye.